Hello students, welcome to Sauras's classes. This video is Infinite Series Part 5. Now, let us consider an infinite series 1 divided by 1 raised to the power p plus 1 divided by 2 raised to the power p plus 1 divided by 3 raised to the power p, so on till infinity. Then this series converges if p is greater than 1 and it is divergent and is divergent if p is less than is equals to 1. Now let us solve it. Case 1, that is p is greater than 1. Now the given series can be grouped as 1 divided by 1p plus 1 divided by 2p plus 1 divided by 3p plus 1 divided by 4p plus 1 divided by 5p plus 1 divided by 6 raised to the power p plus 1 divided by 7 raised to the power p plus so on. Now 1 divided by 1 raised to the power p is equals to 1. 1 divided by 2 raised to the power p plus 1 divided by 3 raised to the power p, this is less than 1 divided by 2 raised to the power p plus 1 divided by 2 raised to the power p, which is equals to 2 divided by 2 raised to the power p, or which is equals to 1 by 2 raised to the power p minus 1. Similarly, 1 divided by 4 raised to the power p plus 1 divided by 5 raised to the power p, 6 raised to the power p plus 1 divided by 7 raised to the power p, this is less than 4 times 4 divided by 4 raised to the power p, which is equals to 1 by 2 raised to the power 2p minus 2. Now if we continue like this, we will get our series 1 divided by 1 raised to the power p plus 1 divided by 2 raised to the power p plus 1 divided by 3 raised to the power p, so on. This would be less than 1 plus 1 by 2 raised to the power p minus 1 plus 1 by 2 raised to the power 2p minus 2 plus so on 1 by 2 raised to the power 3p minus 3 and so on. So this would be less than 1 divided by 1 minus 1 by 2 raised to the power p minus 1, as it is a geometric progression with r is equals to, it is a geometric progression with r is equals to 1 by 2 raised to the power p minus 1. So its sum would be is equals to 1 divided by 1 minus r, or 1 divided by 1 minus 1 by 2 raised to the power p minus 1, which is less than a finite number if p is greater than 1. So when p is greater than 1, then the series is a then our series is a convergent series. Case 2, when p is equals to 1. Now when p equals to 1, then the given sequence becomes 1. Given series becomes 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7 plus so on. Now grouping the series, we get like this. We get now 1 plus 1 by 2 is equals to 1 plus 1 by 2. Now 1 by 3 plus 1 by 4, this is greater than 1 by 4 plus 1 by 4, which is equals to 1 by 2. So 1 by 3 plus 1 by 4 is greater than 1 by 2. Similarly, 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8, this is greater than 1 by 8 plus 1 by 8 plus it's 4 times, or which is equals to 4 by 8 or 1 by 2. So if we continue like this, we will get our series 1 plus 1 by 2 plus 1 by 3 plus so on. This is greater than 1 plus 1 by 2 plus 1 by 2 plus so on. That is, it is greater than 1 plus n by 2. Now when n tends to infinity, this 1 plus n by 2 will tend to infinity. Therefore, our series is greater than infinity. Hence, the series is divergent. When p is equals to 1. Now case 3, that is when p is lesser than 1. Now when p is lesser than 1, 1 by 2 raised to the power p is greater than 1 by 2. Similarly, 1 by 3 raised to the power p will be greater than 1 by 3 and so on. Therefore, 1 by 1 plus 1 by 2 raised to the power p plus 1 by 3 raised to the power p plus so on, this is greater than 1 plus 1 by 2 plus 1 by 3 plus so on. Now, we have already proved that this series is a divergent series. Hence, our series 1 plus 1 by 2 raised to the power p plus 1 by 3 raised to the power p, when p is less than 1, is also a divergent series. Hence, the given series is divergent when p is less than 1. That is, 1 plus 1 by 2 raised to the power p plus 1 by 3 raised to the power p plus so on is divergent when p is less than 1.